Have you ever watched a game of golf? It's all about precision, timing, and that one perfect swing. Well, here at Makerspace, we decided to take that challenge to the next level. Today, we are engineering a robot that can play the game for us. Let's get started. To bring this robot to life, we are using two specific kits here, our physical computing kit and our mechanical kit. By combining the brains of computing with the bones of mechanics, we can create a fully functional golf-playing robot. First, let's look at the brains and the nerves from our physical computing kit that will control our robot. We will be using the physical computing kit's main controller runs our logic, a motor driver to manage the power, a tact switch to trigger the swing, and a high-torque N20 motor to provide the mechanical force. Next up, we need to create the structure. From our mechanical kit, we have a variety of parts to build the frame and the swinging arm. We'll be using blocks and beams for the robot's body, gears and axles for the movement mechanism, an N20 shaft to connect our motor, a pom ball to act as our golf ball, and finally, port cables and jumper wires to bring the whole system to life. Now, let's start with the foundation. To create the base, we are joining two blocks together to form an L shape. We need two of these identical structures to ensure the robot is stable. Next, we'll build the upper base by attaching another block on top. This will hold our swing axle in place. Now, let's slide the axle through. This is the shoulder of our robot that will allow for the golf swing. Once the axle is secure, we attach the L-shaped beam to it. This gives our robot its signature golf stick shape. To make sure the motor can actually move this arm, we'll attach a gear directly onto the axle. With the structure ready, it's time for the brains. Let's mount our controller onto the frame. Once that's fixed, we'll also add our tact switch, which will act as our start button for the swing. As you can see, half of our golf robot is now complete. To power the movement, we're placing the motor driver right on top. After that, we connect our N20 motor. I've chosen this motor specifically because it provides the high torque needed for a strong, fast swing. For the final part of the assembly, we'll join one last gear to connect the motor to the swing axle. Now, look at that. The entire mechanism is synchronized. Our robot is physically ready to play, but it still needs instructions. The hardware is done, so now we just need the code to make it run. Let's take a look at programming. Now for the logic. Our code starts with decision blocks to check if the button is pressed. When triggered, action blocks spin the motor, while wait blocks time the swing perfectly. Finally, we used a loop block at the end, so the robot resets and is always ready for the next shot. Now, let's see how it all works together. When I press the tact switch, it sends a signal to the controller. The motor spins the gears, which turn the swing axle. Because we used a specific gear ratio, the robot gets enough torque to swing the heavy L-beam club with speed. It's amazing to see how the code and the mechanical parts work together to create this perfect swing. It's a perfect mix of electronics and mechanical power. Identify a real-life application of this project in your environment and tell us in the comments. Excited to explore more? Register your child for our robotics course at Makerspace. And don't forget to subscribe to our YouTube channel for more educational videos